Hello, math humans. We're going to do 2.5a today. We're going to be talking about implicit differentiation. Our objectives are that we're going to use implicit differentiation to find derivatives. So let's talk about the different forms. If I have an explicit form equation, that would be y is equal to maybe 3x squared minus 5. And notice that for explicit, that means that the variables are already separated. The y and the x are on opposite sides, and y is separated by itself. Okay? Implicit, on the other hand, might be something like this: xy is equal to 1. Well, this one is easy to separate, and so I would get y is equal to 1 over x, and then my variables would be separated, and then I could take the derivative, right? And so if I wanted to take the derivative of this one, I would get dy dx is 6x, and then if I wanted to take, this is x to the negative 1, the derivative of y with respect to x, it would be a negative 1 x to the negative 2, so a negative 1 over x squared. So explicit means it's easy to take the derivative. Some implicits are easy to take the derivative. The problem comes in when I have an equation, xy squared plus 4y is equal to 2. This becomes a difficult equation to isolate y, which means that doing the derivative is hard, which is when we come to implicit differentiation. That's a long word. All right, so basically here's what happens. So let's say I wanted to take the derivative of this situation. So if you'll notice, this and this are the same variable. And so then I would just get an answer, 3x squared. But what if, and I've mentioned this before, it looks like this. I'm taking the derivative with respect to x, but there's a y. Well, the variables don't match. So then what happens when I take the derivative is I still take the derivative. This would be 3y squared. But because I was taking the derivative with respect to x, then that would generate a dy dx. And the derivative of y with respect to x, and then I would have to solve for dy dx. So I'm going to tell you a basic rule. So here is your basic rule, is if you take the derivative of a y term, you're going to generate a dy dx. And that's going to be because of the situation we just explained. In this situation, the variables matched. In this situation, the variables don't match. And we'll talk more about this in the next couple of sections. But when I take the derivative of a y thing, it generates a dy dx. And then the next step of the problem is solve for dy dx. Okay? And so now I'm just going to do a series of examples because I think that will help it to make more sense. So for example number 1, I have x plus 3y, and I want to find dy dx. And so in all of the other work that I've done, I would write down I'm taking the derivative, and then I would do my work. But because I'm doing implicit, because there's a y, what I write is derivative. And that's just my own notation. Well, the derivative of x is 1. The derivative of 3y is 3 dy dx, okay? But if I'm trying to find dy dx, then I would separate or isolate, so I would get 3 dy dx is a negative 1, and then if I solve for dy dx, I would get a negative 1/3. And that would be the derivative of this equation of y with respect to x, okay? Let's do another example. So I want to find the derivative of xy squared. So a couple of things to notice. For starters, this is the product rule because I have two things multiplied together. And to notice, I'm going to have an implicit differentiation because the y and the x are attached. Okay? So now I'm going to start my derivative, and I'm going to have the first thing times the derivative of the second, 2y, remember it generates a dy dx, plus the second thing times the derivative of the first, which is 1. The goal is to solve for dy dx, okay? So I'm going to take this guy to the other side, so 2xy dy dx is a negative y squared. I'm going to isolate and solve, so dy over dx is going to equal a negative y squared over 2xy. One of the y's cancel, so it's a negative y over 2x. And then I write my conclusion statement at the end. It's a negative y over 2x. And so that was fairly polite. The thing you have to remember is with implicit differentiation, if you take the derivative of a y term, you're going to generate a dy dx, and then you're going to have to solve for dy dx. The third example says find dy dx, and I'm going to have y cubed plus y squared minus 5y minus x squared is equal to a negative 4. And if you look at this equation, sometimes you can solve for y, and it's pretty easy. I don't think I could solve for y, but implicit is pretty easy. So when I do my derivative, I'm going to get 3y squared dy dx plus 2y dy dx minus 5 dy dx minus 2x equals 0 because the derivative of a constant is 0. I'm going to factor my favorite f word. My dy dx is out, and I get 3y squared, 2y minus 5. Take that guy to the other side. I'm still trying to solve for dy dx. Sorry, I'm really hoarse today. This is 2x divided by 3y squared plus 2y minus 5. And we're done. The other thing to notice right here is think about this. dy dx is the slope. In all of our other math that we've done up until this point, my derivative might only have an x. And so when I evaluated the derivative at a point, I only had to substitute in the x value. Well, now if I choose to evaluate the slope, now my slope is in terms of x and y. So if I were to evaluate this particular slope at a point, now I could substitute in both the x values and the y values. So I think that's kind of cool. All right, our next example, this is going to be example number 4, says determine the slope of the tangent line to the graph of x squared plus 4y squared equals 4, and I want to do it at the point radical 2 negative 1 over radical 2. So this is that situation that we just talked about. Now when I find, this is a y by the way, when I find my slope, I can substitute in both an x and a y value. So if I start by doing my derivative, I'm going to get 2x plus 8y dy dx is equal to 0, right? Remember when I take the derivative of a y, I get a dy dx. So then my 8y dy dx is a negative 2x. Then dy dx is a negative 2x over 8y, which is a negative x over 4y. Okay? All right, so that's going to be my generic rule to help me find my slope. All righty? And it says determine the slope, so I'm going to evaluate this at the point radical 2 negative 1 over radical 2. So now if I substitute those values in, that's going to be a negative radical 2 over 4 times a negative 1 over radical 2. Okay, I do need to simplify a little bit. Here's the radical 2, and then I have a negative 4 over radical 2. Fraction divided by a fraction, I get the reciprocal. So dy dx evaluated at radical 2 negative 1 over radical 2 is going to equal a negative radical 2 times radical 2 over a negative 4, which is going to be 2 over 4, which is a half. And then I would report my answer well. And notice how I reported. Evaluated at the point radical 2 negative 1 over radical 2 is equal to a half. This shows that I evaluated the derivative at this point to get this value for slope. Okay? Alrighty. So now let's do another example, and I think this is our last one. So this is example 5. And it says determine the slope of the graph of 3 times x squared plus y squared squared is equal to 100xy at the point 3, 1. Okay, move it down so you can see all of the words. That would be helpful. So when I look at this, I think several different things. The first thing I notice is this is implicit differentiation, okay, because I can't solve for y. The second thing I notice is that I'm going to have the chain rule, and then I notice over here, third thing, that this is the product rule, okay, and you could take everything to the same side, but at this point I'm just going to leave it. So I'm just going to start doing some math. So when I take my derivative, remember we always we identify our work just like we do our answers. It's going to be 3 times 2. What starts inside stays inside to the first, times the derivative of the inside, which is 2x plus 2y. Remember, y thing means a dy dx, is equal to, and I'm going to attach the 100 to the x, the first thing, times the derivative of the second plus the second thing times the derivative of the first. Okay? So now what I'm going to do is I look through my problem. I'm going to simplify a little bit. So I have 6x squared plus 6y squared. And then I have a 2x plus 2y dy dx is equal to 100x dy dx and 100y. This is a little bit hard to separate, so what I'm going to do is I'm going to distribute these terms because I need to isolate the dy dx's. So if I multiply, I get 12x cubed plus 12x squared y dy dx plus 12xy squared plus 12y cubed dy dx, and here's the 100x dy dx and the 100y. Now I have to get, and yes, I can do some factoring and reduce, but for right now I'm going to isolate my dy dx's. And I'm going to factor and move things at the same time because I'm in big kid math. So I'm going to do dy dx, and I'm going to get 12x squared y plus 12y cubed minus 100x is equal to 100y minus 12x cubed minus 12xy squared. Okay? And I just did it all in one step just to minimize because I've already written a lot. Remember, the goal is still to solve, for dy dx, so I get dy dx is equal to 100y minus 12x cubed minus 12xy squared, and I'm going to divide by 12x squared y, 12y cubed, and 100x. Alrighty, so that is my derivative. Whoo, isn't that messy? So now I want to evaluate the derivative at the point 3, 1. Okay, So now it's just a matter of simplifying and substituting in numbers. So I'm looking for the slope at this point. And I could have probably simplified this more. I could have factored out some numbers, and at this point I'm going to choose not to, because at this point I have a bunch of math to do. So this is 100 times 1 minus 12 times 3 cubed minus 12 times 3 times 1 squared over 12 times 3 squared times 1, 12 times 1 cubed minus 100 times 3. I would do all of that math in my calculator, making sure that I put the numerator and the denominator in separate parentheses, and you're going to get 13 over 9. Whew! So then I'm going to report dy dx evaluated at 3,1 is equal to 13 over 9. Now let's talk about grading. If I am grading your paper, or if a grader is grading your paper, one of the things that I check is that you have the correct derivative. So this needs to be labeled, and you need to show that you're going to evaluate that derivative at a given point. And then you would write your answer statement down at the bottom when you are done. So in calculus, it is just as important to identify your work as it is the solution. So you always want to make sure that you do both. Alrighty, that's it for today. I will see you soon.